All right. Today we're going to talk about classifying triangles and quadrilaterals. It's not a terribly difficult conversation to have. It's not a very difficult lesson by any means. So we're going to go ahead and get started. If you look in your book at page 318, you'll notice a variety of the triangles are already there. So really the trick to this is figuring out what makes them unique. Why are they labeled the way they are? Okay, so let's go ahead and first of all start by labeling our notes. This is going to be PA, lesson 7-4. And it's all about classifying. I'm going to draw pictures for this. Triangles and quadrilaterals, or four-sided figures. Not rectangles, quadrilaterals. Okay, I will tell you this. We'll start with triangles. And triangles really have two main things that we classify them by. Okay, it's not necessarily in your book, but this is basically, if you look at the definitions, Mr. Chantelet, you will see that they're broken up into two categories. The first one being by angle, or angles, and the second being by sides, or side or sides. Okay, so if all of the angles in a triangle are less than 90 degrees, what do we have? Does anyone know what kind of triangle do we have? Yes. We have an acute triangle. Okay, so if all of the angles are less than 90 degrees, so acute means all angles less than 90. And I'm probably going to need to erase this sides thing for just a moment because I'm going to need room. Okay. What about a triangle that has a right angle? A right triangle. Okay. So if it has one right angle, I will tell you this, triangles can never have more than one right angle. That's it. They can only have one. All right. For all of the sides to meet and for there to be three sides only, you can only have one right angle. So a right triangle is one where you have one and only one right angle. The other two will be acute angles, but it has one right angle, and that's the angle that we classify it by. If I were to draw an acute triangle, it'd look something like that. If I were to draw a right triangle, something like that. And here we go with the, which is the last one, is the what? Obtuse. And that means it has one, because it can only have one obtuse angle. But that one angle is enough to classify it as an obtuse triangle. Okay, and an obtuse triangle would look something like this. You have the base of the triangle, and that obtuse angle would be right there, and you can see it. Nope, it's a little arc. It's a little arc. Okay, so these are your three different triangles by angles. Okay, so if you hear acute, right, or obtuse, then you're dealing with angles. Okay, those are the key fundamental terms. But then there are three terms that deal with sides. Okay, so let's switch over now to the next kind of set of definitions. All right, you have three terms here. You have equilateral, okay, you have isosceles, which you're probably familiar with, and scalene, and that's always the hardest one. Okay, equilateral, that one's pretty straightforward. What can you tell me about the sides if we have an equilateral triangle? Reagan? They're all the same. Yep. So if I were to draw an equilateral triangle, and actually that's not a good equilateral triangle. Let me try to draw one here. Okay, that would be an equilateral triangle. We know they're all the same because we put a single dash on all three sides. What about an isosceles? Yeah, Emma. Has at least two, well, it can only have two congruent sides. Very good. Okay, so that would be an isosceles triangle. There's only two dashes.
Why does it say in the book at least two?
At least two? Because I suppose you could classify an equilateral triangle as an isosceles triangle. I prefer to just view it as just two. Okay. And then scalene. What's unique about a scalene? Gloria? None of them are the same. A lot of right triangles are scalene triangles. Okay, where you have 1, 2, and 3 different sides. And put two dashes on the bottom of that scalene too, so we know that that's a different side. So you can classify triangles by angle, sides, or both. Okay, or both. So let me give you an example of what this might look like. Okay, let me give you a list. You can have an acute equilateral triangle. Okay, actually all equilateral triangles are acute triangles because the sides are equal. All the angles inside an equilateral triangle are 60 degrees. So all equilateral triangles are acute triangles. Okay? Emma?
Wait, so like an acute triangle or an equilateral triangle could never be obtuse?
You're right. An equilateral triangle will never be a right triangle or an obtuse triangle. It will always be an acute. You can, however, also have an acute isosceles. And you can also have an acute scalene. Okay, so those are three different acute triangles you can have that are also equilateral, isosceles, and scalene. As far as right triangles go, you only have two options. You can have a right what? Mary?
Isosceles?
Yep. And you can also have a right scalene. Last but not least, you can have an obtuse isosceles and an obtuse scalene. These are the 7 types of triangles that you can have. They almost always fall into these categories. Okay, let's go ahead and draw them. Equilateral triangle, an acute equilateral is going to just be a regular equilateral triangle. However, an acute isosceles, okay, is going to be a triangle where all of the angles are less than 90, but you have two equal sides. An acute scalene, or yes, an acute scalene triangle would be like one in your book. Like that, where all the sides are different, but all the angles are less than 90. They can be close to 90, but that is not a 90-degree angle on the top there. Now, a right isosceles triangle is going to be one where you have a right angle and two sides that are the same. And a right scalene is our basic standard right triangle, where three sides are different and you have a right angle. Our obtuse isosceles, okay, our obtuse isosceles would be something like this. Okay, and the obtuse angle is this one here. Notice that it's not a right angle. I put the arc there to indicate that it's obtuse. An obtuse scalene would be something like that, where those two sides are just a little bit, or all the sides are just a little bit different. So there's our 7 different types of triangles. Every triangle that you see falls into one of these 7 categories, okay? Broken up by both sides and angles, okay? You can use those classifications. Sometimes your book will want you to classify by just side or just angle, or sometimes they want you to classify by both, okay? So those are your 7 examples. Those are triangles. That's how we classify them. Now, quadrilaterals. I love quadrilaterals. Okay, you'll notice that there's something called a hierarchy in your book. All right, so we're going to use this hierarchy a little bit. We're going to start at the top of your notes. We're going to start with all quadrilaterals, all four-sided figures are quadrilaterals. All four-sided figures are quadrilaterals. Oh, I love quadrilaterals. 4 sides is the way to go. Okay, even though triangles are the strongest. Okay, quadrilaterals are still really cool. Now, when we look at a quadrilateral, okay, what we have to first notice is that there are several different types. Okay, but what we need to understand is that the sides have relationships. Okay, the sides have relationships. Some sides are parallel, some sides are not. There are possibly right angles, there are possibly not right angles, there's possibly opposite angles, etc. Okay, so when we're looking at quadrilaterals, 4-sided figures, we need to take into consideration that there are different, okay, definitions or pieces of them. So let's work through this hierarchy a little bit. First of all, and you can see this in your book, quadrilaterals, the main term is broken down into 2 types. Okay. Trapezoids on to the right trapezoids have only one pair of parallel lines. Okay? So if you come across a quadrilateral that has only one pair of parallel lines, okay, it's a trapezoid. However, it can still be a trapezoid, or if you come across something that has 2 sets of parallel lines, now we're entering into the parallelogram, which is an awesome word. Say it after me. Parallelogram. 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 Oh, I love it. It's fun. Ah, parallelogram. Oh, it's a great word. Great word. Okay, because it's just not fun. Both sets of sides, or both pairs of opposite sides, the reason that we choose to use a hierarchy with quadrilaterals is because a lot of things fall into the parallelogram category. Okay? Trapezoids, let me draw a little picture for you. Trapezoids have there are a couple different types. There's right trapezoids and there's non-right trapezoids. Let me show you both. A right trapezoid looks something like this. And I'm going to put a little dash here and a little dash here, and that means that the lines are parallel. Okay, notice that this one has two right angles. That's what we call a right trapezoid. However, a non-right trapezoid would be probably the one you're most familiar with. And that's going to be the one where you've kind of seen it in tangrams and things like that. This is called an isosceles trapezoid. Okay, where you have two sides that are the same, and then you have the parallel lines in top and bottom. Okay. Last but not least, there's the scalene trapezoid. Where you have the parallel lines in top and bottom, but then you have two different sides. So kind of here we see the angle classification come back into play. There are three different types of trapezoids here, but these are all trapezoids because they have four sides and they have only one pair of parallel lines. Okay, and I'm even going to highlight the parallel lines so they're very easy to see. Okay, it's very important that you see these parallel lines at work. Okay, now parallelograms, there's a lot of different parallelograms. Parallelograms are things that look like that. Oh, that's kind of messed up. That. They're not. And I'll show you why. Those are four different types of parallelograms. Okay? The reason that the two top ones are not the same is that one's wider than the other. Okay? Here, all four sides are the same. We call that a square. Here, the two side sets are different lengths. Here, the two side sets are different lengths. Here, all the side sets are the same. Each one of these is a unique quadrilateral, but they're all parallelograms because they all have two sets of parallel lines. Okay, and it's trying to show up on that top left figure, the lines. Hopefully it'll show up here in just a second. There it is. Okay, so can anybody name these four different figures? You have the book in front of you, but let's see if you can identify them. Yeah.
There's a rectangle, a square.
Hang on a minute. Which one's the rectangle?
The bottom right.
Yep, bottom right is a rectangle.
And then the bottom left is a square.
This is a square.
The top left is a rhombus.
Yep, this is a rhombus.
And then the top right would just be parallelogram.
Right. This would be just a parallelogram. You're correct. What makes the rhombus and parallelogram so different than the square and rectangle? Yeah. Doesn't have, but neither does the rectangle. What makes them different, Erica? Look at them carefully. Rectangles and squares have to have four right angles. That's what makes them different than rhombuses and parallelograms. So we're not only breaking it down by sides, but we're also breaking it down by angles. Okay? And you can kind of see that in the hierarchy on page 319. You see that we break a rhombus down into four congruent sides, a rectangle down into four right angles, but then a square takes into consideration both of those things. Mary.
Couldn't you just say, like when Jane was naming them, couldn't you just say that's a
You could. But your book is going to ask you to classify figures as many different ways as you can. So you would have to a square is literally a rectangle, a rhombus, and a parallelogram, and a quadrilateral. It's all four, and a square. It's 5. A square has 5 classifications.
Should we write all 5 down in our homework?
If it asks you to write down every classification for a figure, you need to do that. Okay? Well, no, it's just called thinking, but that maybe for you is a lot of work. That's fine. Okay? So, let's finish our hierarchy. You should copy this in your notes. Writing it down helps as well. Okay? Rhombus and rectangle. We call this the R level. Okay? Rhombus deals with 4 congruent sides. Whereas the rectangle is 4 right angles. And they both come together, and when both things are taken into consideration, you have a square, which is everything. It's both pairs of opposite sides are parallel, it has 4 congruent sides, and it has 4 right angles. I'm just going to put right next to it, it is everything. A quadrilateral, a rhombus is a quadrilateral. A rectangle is a parallelogram, a rhombus is a parallelogram, a square is a parallelogram, okay? Yep. So it's kind of like starting at the bottom. Is it a square? No. Is it a rhombus or a rectangle? No. So maybe it's just a parallelogram or a trapezoid. If it's not a trapezoid, it's a parallelogram. So it's almost better to start at the bottom and work your way to the top. Okay, start with the most specific and work your way up. So that actually can go both ways. Okay? Any questions about this? Any questions? Jaden?